Welcome students. Today we are going to start part 3rd of carbon and its compounds. The next amorphous form of carbon is the gas carbon. And how this gas carbon is prepared? It is also prepared by the destructive distillation of coal or petroleum substances. At high temperature, in a closed container, carbon particles are deposited on the wall of container, which is that we called as a gas carbon. And dear students, this gas carbon is a grey solid and it is also a good conductor of heat and electricity. Which are the uses of gas carbon? The first use of this gas carbon is it is used for making electrodes. Then second one, it is also used to make the lining of electrolytic cells. Then it is also used to make the carbon rods for the arc lamps. Now we are going to start the part C, that is the carbon dioxide. Students, the molecular formula of this carbon dioxide is CO2 and the relative mass of this carbon dioxide is 44 atomic mass unit. And the one molecule of carbon dioxide is made up of one carbon atom and two oxygen atom. Next point about carbon dioxide is the discovery. Who discovered this carbon dioxide? The carbon dioxide, you have learned about that. It is the most important constituent in the air. And it was discovered by the name of the scientist is that Van Helmont in 1630 by burning the charcoal in air. But after that, the name of that scientist is the Joseph Black. He studied the properties. After that, Anthony Lavoisier studied the properties of carbon dioxide. He gave the name for that acid carbonate. Next topic of the carbon dioxide is the occurrence. Dear students, carbon dioxide occur in free state also and in combined state also. First we will discuss about the free state. Carbon dioxide occur in free state 0.03% to 0.04% in air. Then again it is also occurs in the rocks of that volcanic regions. It is also present in water as dissolved state. And that dissolved state of this carbon dioxide used by the aquatic plants for the process of photosynthesis. And now students, in combined state. In combined state, this carbon dioxide also occurs as the metallic carbonates and bicarbonates in the earth crust. And it is also present in the seashells. So these are all about the occurrence. Now, preparation of carbon dioxide by different methods. First method by burning carbon and its compounds. The burning of charcoal or coke or carbon compounds produces carbon dioxide. First one, carbon. So carbon burn with oxygen, it produces carbon dioxide. And this is the chemical equation for the burning of carbon. Second one, carbon compounds. One example is the methane. Methane reacts with oxygen on burning and it produces carbon dioxide and water. So this is the chemical equation for the carbon compounds when burned in oxygen. And the second method, by heating metal carbonates and bicarbonates. Metallic carbonates and bicarbonates decompose on strong heating to produce carbon dioxide. And the chemical equation for this metal carbonate is that copper carbonate on strong heating produces the copper oxide and carbon dioxide. This is the first example for the carbonate. Now what about the bicarbonate? Sodium bicarbonate on strong heating producing sodium carbonate, water and carbon dioxide. Now students, the third method for the preparation of carbon dioxide by the action of dilute acids on metallic carbonates and bicarbonates. Dilute acids are used, dilute hydrochloric acid and dilute sulfuric acid. First we will explain about the dilute hydrochloric acid. Calcium carbonate react with dilute hydrochloric acid, it producing calcium chloride and water and carbon dioxide gas. The next example for the dilute sulfuric acid. Sodium carbonate react with the dilute sulfuric acid and it forms the sodium sulfate, water and carbon dioxide. Sodium bicarbonate react with dilute hydrochloric acid, it gives the sodium chloride, water and carbon dioxide. And now students, the next topic of this carbon dioxide is the laboratory preparation of the carbon dioxide. And which chemicals are required for the preparation of this carbon dioxide in laboratory? The first one is the marble chips, and that marble chips we called as a calcium carbonate. Second one is the dilute hydrochloric acid. These two chemicals we are using for the preparation of carbon dioxide in laboratory. Why we prefer the marble chips, that is calcium carbonate? Because it is easily available and it is very cheap. And second one, why we prefer dilute hydrochloric acid for the preparation of carbon dioxide in laboratory? It is because when the dilute sulfuric acid, it react with the metallic carbonate, so it formed that sulfate and that sulfate deposited on the water. Calcium sulfate which is formed during the reaction is insoluble in water and it covers the marble chips and stop the reaction. So that is the reason for that we should use the dilute hydrochloric acid instead of the dilute sulfuric acid. Okay, now students, I am going to explain the procedure for this preparation of carbon dioxide. A wool's bottle is taken and some marble chips are placed in it. Through the mouth of the bottle, a thistle funnel is introduced with the help of a rubber stopper in such a way that its stem dips in the acid kept in the bottle. Through the second mouth of the wool's bottle, a delivery tube is fitted. The other end of the tube is put in a gas jar. Now, dilute hydrochloric acid is poured into the bottle through the thistle funnel so that the marble chips are completely immersed in the acid. Immersed means students completely deep. After that, a vigorous chemical reaction takes place and carbon dioxide gas is released. And whenever students the gas is released, it with a brisk effervescence. First few bubbles of carbon dioxide are allowed to escape and they might contain maybe air and acid as impurities. That's why we have to not collect that. Then after that, the gas is allowed to pass through the delivery tube and into a gas jar where it is collected by upward displacement of air. Because carbon dioxide is heavier than air, carbon dioxide is highly soluble in water. That's why carbon dioxide is not collected over the water. This is the reason for that. Now we will start our next topic, that is the properties of carbon dioxide. And the first point, physical properties of carbon dioxide. Now students, which are the physical properties of this carbon dioxide gas? The first one is the nature. Carbon dioxide is colorless, odorless gas, but a faint acidic taste because it is acidic in nature. And the second one is the density. Under ordinary conditions, this carbon dioxide gas is 1.5 times heavier than air. Third physical properties about solubility. It is fairly soluble in water and its solubility increases with increase in pressure, and that's why students, this carbon dioxide gas is used in carbonated drinks. The next one is the liquefaction and solidification into dry ice. Carbon dioxide can be liquefied under pressure when the liquid carbon dioxide is cooled at negative 78 degrees Celsius under the normal pressure. If this carbon dioxide changes with the ice, dry ice directly change into the gaseous carbon dioxide from that its solid states, and that's why the dry ice is called as a sublimable substance. And the fifth physical property is the physiological reaction. This carbon dioxide is non-poisonous gas, but excess of this gas causes the suffocation. And now students, the next point is the chemical properties of carbon dioxide. First chemical properties of this carbon dioxide is the combustibility. Carbon dioxide is neither combustible nor supporter for the combustion. So it will not burn and it not support for the burning also. Second property, action with the litmus paper. Carbon dioxide turns that moist blue paper into red, and that's why we call carbon dioxide is acidic in nature. Next property, the next one is reaction with water. Carbon dioxide dissolve in water to give the carbonic acid. Yes, carbonic acid is producing. And the chemical equation for this reaction is like that. Carbon dioxide react with water forming carbonic acid. The next chemical property of the carbon dioxide, reaction with alkalis. And carbon dioxide reacts with alkalis to produce salt and water. For example, sodium hydroxide is the alkali. It reacts with carbon dioxide forming sodium carbonate, that is the salt, and water. When excess of carbon dioxide pass through alkalis, a soluble bicarbonate is obtained. And the fifth property of the carbon dioxide is that reaction with metals. Metal react with carbon dioxide forming its metal, that is the metallic oxide, and carbon is forming. For example, magnesium is the metal. Magnesium reacts with carbon dioxide, it forming magnesium oxide and carbon. The next property is reaction with metallic oxides. Metallic oxides react with carbon dioxide and it producing metal carbonates. For example, students, if sodium oxide react with water, it forming sodium carbonate. Its metal carbonate is forming. Next chemical property is reaction with the non-metal. Carbon dioxide is react with non-metal producing highly poisonous gas. For example, carbon dioxide react with carbon, it forms the carbon monoxide. How to test this carbon dioxide gas? The first test for the carbon dioxide is that carbon dioxide turns the moist blue litmus paper into the pinkish red color. The second test for the carbon dioxide is that if a burning candle we will keep in a jar, it will stop for burning. Means students, carbon dioxide is non-supporter for the burning. And the third test for the carbon dioxide is that when carbon dioxide is passed through that lime solution, it turns into the milky. And excess carbon dioxide, so we will pass that gas, the milky color will disappear. So these are the three tests for the carbon dioxide gas. And now students, the next topic is the uses of carbon dioxide. The first use in aerated drinks. Carbon dioxide is used in the manufacture of aerated drinks because the gas is dissolved in water under pressure to give the soda water. Second use, refrigeration and preservation of foodstuff. That solid carbon dioxide dry ice, it is used as a coolant and refrigerant in ships for preserving food articles like fruits, vegetable, meat, etc. In hospitals, a mixture of 5% carbon dioxide and 95% oxygen called as a carbogen. It is used for artificial respiration. Fourth use in the manufacture of fertilizers. Urea is an important nitrogenous fertilizer and it is prepared when carbon dioxide and ammonia are heated at 150 degrees Celsius under very high pressure. Fifth use in the preparation of chemicals. Carbon dioxide is used to manufacture chemicals like washing soda that we called as a sodium carbonate, then baking soda that we called as a sodium bicarbonate. In the baking industries, carbon dioxide is used to make the dough rise and become light. Next use of carbon dioxide in photosynthesis. Carbon dioxide is used in photosynthesis, a natural process to prepare the food by the green plants, and the food is prepared is also used by animals. Then eighth one is in extinguishing a fire. When a substance burns with a flame, the heat, light and often the smoke so produce that constituent fire. This carbon dioxide helps in extinguish the fires because it neither burns nor does it help in burning, being heavier than air, and it insulates the burning substance by cutting off the supply of oxygen. And you have learned oxygen is a supporter for burning. The first one is the fire extinguisher. Fire extinguishers are the device in which carbon dioxide is produced in different form to be used as an extinguishing agent. Some common types of these fire extinguishers are soda acid fire extinguisher, foam based fire extinguisher, then liquid carbon dioxide fire extinguisher. The first one is soda acid extinguisher. It contains sodium bicarbonate and sulfuric acid in separate chambers. Then the extinguisher consists of the metallic cylinder filled up with 2/3 with a saturated solution of sodium bicarbonate. A sealed glass bottle containing concentrated sulfuric acid is kept inside the cylinder, and this cylinder is inverted and make it heat. So as a result, the gas bottle with the acid breaks and the two chemicals come in contact to react and produce carbon dioxide gas. And it spread over the fire and cut off the supply of oxygen to it, and hence the fire is extinguished. Here we completed our part 3rd up to the uses of carbon dioxide. Thank you.